My current diet contains a lot of oxalate. For example, I eat a lot of spinach, and spinach is a rich source of oxalate, ranging from 460 to more than 1100 milligrams per 100 grams of spinach. So for the 49-day period that corresponded to blood test number 2 in mid-March, I averaged about 138 grams of spinach per day. So when multiplied by the amount of oxalate found in steamed spinach, that yields about 1100 milligrams of oxalate per day just from spinach alone. But that's not the only source of oxalate that I get in my diet. I also eat a lot of beets. So for blood test number 2, again, that 49-day period that corresponded to that blood test, I averaged about 195 grams of raw beets per day, and when multiplying those values, yields about 125 milligrams of oxalate per day. And last but not least, oxalate is also found in carrots, and I eat a lot of carrots, in particular raw carrots. So for blood test number 2, I averaged about 337 grams of carrots per day, which when multiplied by the amount of oxalate found in raw carrots, yields 148 milligrams of oxalate per day just from carrots. So when summing these three foods, just from these three foods, I get almost 1,400 milligrams of oxalate per day. So is this amount of oxalate potentially bad for health? So with that in mind, let's take a look at data from this recently published study, Dietary Oxalate to Calcium Ratio and Incident Cardiovascular Events, a 10-year follow-up among an Asian population. So the key words here are dietary oxalate intake and the incidence of cardiovascular events. But also note that in the title, we see that calcium may affect this relationship. So let's jump into the data and see how it goes. So here we're looking at risk for any cardiovascular disease, CVD-related event versus the dietary oxalate intake. So first, it's important to define what were the CVD-related events. So CVD-related events included probable and definite myocardial infarction, so heart attack, unstable angina pectoris, which is chest pain that worsens, angiographic confirmed coronary heart disease, so atherosclerosis as confirmed by angiography, and then any cardiovascular death, including a fatal heart attack, coronary heart disease, so atherosclerosis, or stroke. All right, so what's the association for dietary oxalate intake with these cardiovascular disease-related events? So dietary oxalate was divided into three tertiles, low, medium, and high. So low oxalate intake was had a median value of 120 milligrams of oxalate per day. Tertile 2 had 181 as a median value, and tertile 3 had 277 as a median value. So right from the start, we can see that I would at least fall into tertile 3, the highest oxalate intake group. So let's take a look at the association for dietary oxalate intake with CVD event risk. So that's the crude association unadjusted. And when compared with people who were in the lowest tertile for oxalate intake, we can see that there's a statistically significant association for oxalate intake with CVD events. In particular, people who ate in tertile 2, 181 milligrams of oxalate per day, and in tertile 3, we see significantly increased risk for cardiovascular disease events in association with higher oxalate intakes, so more than 181 milligrams of oxalate per day. But note that many factors can impact this association, the association for dietary oxalate intake with cardiovascular disease events. So what might those be? So that's what's shown here. We're looking at data on the left for people that had a cardiovascular disease-related outcome on the left and people who did not on the right. And you can see the total sample size for this study was about 3,000 people. So note that people who did have a CVD-related event were older, more men than women. There were more smokers. They had a higher BMI, a higher waist circumference, so greater abdominal adiposity, greater fatness in the abdominal region. They had a higher blood pressure, as indicated both by systolic and diastolic. People that had a CVD events had higher glucose, higher triglycerides, lower HDL, and then worse kidney function, as indicated by a higher serum level of creatinine, CR, which is used to derive eGFR, so a lower eGFR in people that had more CVD events or had a CVD-related outcome. All right, so now that we've seen these data, it's important to note that any statistical model that looks at the association between dietary oxalate intake with CVD event risk should include adjustment for these variables. So did they adjust for these variables in the study? So let's take a look at what they included for Model 1. So Model 1 included data for age, TC, total cholesterol, HDL, systolic blood pressure, but interestingly not diastolic, treatment for hypertension, HTN, smoking, and type 2 diabetes, which accounts for elevated glucose levels. So then what was the association for dietary oxalate after adjusting for these factors? So when compared with the lowest oxalate intake, we can again see a statistically significant association between oxalate with CVD event risk. And this is true now only for the highest oxalate group, but not for the intermediate oxalate group that had an intake of 181 milligrams of oxalate per day. So from this, we can conclude that after accounting for Model 1 variables, a relatively higher dietary oxalate intake is still significantly associated with an increased CVD event risk. All right, so what about the other models? So in Model 2, they included Model 1 variables and adjusted for kidney function with eGFR. And when compared with the lowest intake of oxalate, we can see that there is a significant association as indicated by the p-value, 0.03. And this is true for the highest oxalate intake group with a 60% increased risk for a CVD event, but not for the intermediate oxalate intake group, which you can see by that confidence interval in parentheses 0.93 to 1.89. It overlaps with 1. So when the confidence interval overlaps with 1, it's not statistically significant. So we can adjust our summary statement to also include Model 2 variables. So after accounting for Model 1 and Model 2 variables, that the relatively higher dietary oxalate intake is still significantly associated with an increased CVD event risk. All right, what about Model 3? So in Model 3, it included Model 1 and Model 2 factors, but then also it adjusted for calorie, fat, and fiber intake. And now we can see that statistical significance is lost, but note that for the highest oxalate intake group, that confidence interval is still completely above 1. It doesn't overlap. So there is a 47% increased risk for CVD events after adjusting for all these variables in people that had relatively high 200 with a median value of 277 milligrams per day of oxalate, but not for the intermediate group. So again, as you can see, we can annotate our summary statement to, after adjusting for all these variables, a relatively higher dietary oxalate intake is still significantly associated with an increased CVD event risk. All right, so if you remember in the title, we saw that dietary calcium may affect the association between oxalate intake with CVD event risk. So how does dietary calcium intake affect this association? But before going there, it's important to ask, why should we expect that calcium can impact this association? So dietary calcium impacts the absorption of dietary oxalate into the blood. And that's what's illustrated here. So when looking at the intestinal tract, free oxalate anions, OX2- right there, are absorbed into the systemic circulation as shown there. And then once in the blood, they can then travel to and accumulate into structural tissues and organs where they can then potentially adversely affect health. So in the presence of calcium, though, calcium binds to oxalate, which then targets it for excretion, first in feces, as shown there. So a relatively higher dietary calcium intake should lead to reduced absorption of dietary oxalate into the systemic circulation, leading to less accumulation in target tissues and organs, and then potentially less affecting overall health. Now, note that that's not the only way to, calcium intake is not the only way to potentially reduce oxalate absorption or to get rid of oxalate. And the other way is free oxalate in blood can be urinated. We can pee it out. And we can do that when there's good kidney function. But when there's poor kidney function, less oxalate is excreted via urine. So that illustrates the importance of having good kidney function if you're eating a potentially high oxalate containing diet. Now, note that diet and kidney function aren't the only ways to potentially reduce oxalate's amounts in the blood. Note that the liver and also red blood cells, although I haven't illustrated it on this slide, the liver can produce oxalate via glycolate metabolism as shown there. And then once the liver produces it, it can be released from the liver or released from red blood cells, and where it can lead to accumulation in blood. So now that we know that calcium affects oxalate absorption into the blood, now we can address that question. How does dietary calcium intake affect this association for oxalate intake with CVD event risk? So here we're looking at risk for any CVD-related event versus dietary oxalate intake in people consuming low, medium, or high calcium diets. And this is data from the same study that was listed on the opening slide. So again, we've got our three tertiles of oxalate intake, 120, 181, and 277 as median values for each of those three groups. But then we've got people who are eating a low calcium diet, and this was defined as 760 milligrams per day. And we can see that calcium impacts the association for oxalate with CVD event risk as the p-value for that association, we can see that it's lower than 0.05, so that's a statistically significant association. So what does the data show? So when compared with people on a low oxalate, low calcium diet, people that were on a relatively higher oxalate, low calcium diet, both tertile-2 and tertile-3 had significantly increased risk for a CVD event. 92% increased in tertile-2 and 142% increased in tertile-3. So a relatively higher dietary oxalate intake, more than 181 milligrams per day, is significantly associated with an increased CVD event risk in people consuming a low calcium diet. So what about CVD event risk on higher calcium containing diets, both the medium and high calcium diets as shown there? So in the medium calcium diet, these were people that that had a median calcium intake of 1180 milligrams per day, and on the high calcium diet, the median intake was 1760 milligrams per day. And we can see from the p-values that there weren't any significant associations between dietary oxalate with CVD event risk after accounting for calcium intake in the medium and high calcium groups. So let's just take a quick look at that data. So when compared with the lowest oxalate intake and medium and high calcium diets, we can see that the confidence interval for both tertile-2, 0.61 to 2.28, and 0.67 to 2.51. So you can see it overlaps with 1. So tertile-2 is not significantly different from tertile-1 data. And similarly, tertile-3, we can also see the overlap for the confidence intervals both on the medium and high calcium diets when compared with the lowest oxalate intake, tertile-1 versus tertile-3. So although a relatively high dietary oxalate intake, more than 181 milligrams per day, is significantly associated with an increased CVD event risk in people consuming a low calcium diet, this is not true, at least based on this study, for people consuming more than almost 1,200 milligrams per day of calcium. So to bring it back to the original question, is my oxalate intake of about 1,400 milligrams per day, at least 1,400, bad for health? We can put my data into context. So first, I would fall into tertile-3, as mentioned before, with a median value of 277. I'm clearly within that group with almost 1,400 milligrams of oxalate per day. But then my average daily calcium intake for blood test number 2 was 1,219 milligrams per day. And if for those who don't know, I use a food scale. I weigh all of my food and then log that into an online app. So this is as close to as accurate of a calcium intake as it can be as I'm weighing all my food and logging it. So 1,219 milligrams per day for calcium would put me in the medium calcium diet. And when looking at the data for that, we can see that having a medium calcium diet but high oxalate was not significantly associated with an increased CVD event risk when compared with lower oxalate intakes on a medium calcium diet. So based on that, I may be okay. No increased risk for CVD based on my relatively high oxalate intake, but mostly because of my relatively high calcium intake. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon. Thanks for watching. I hope that you enjoyed the video. Have a great day.